Hello, let's go on a quick video tour of my 1-pound ant weight Meltybrain Battlebot, Pac-Attac. Got its name right there, Pac-Attac. I've already unscrewed the 4 screws holding it together, so we're going to take the top off here. All 3D printed, by the way. And inside here, we've got the battery. It's a 2S LiPo right there, and let's see, we've got, you're probably wondering what this is. This is a vibration motor, and ended up not really needing it, but I just kind of kept it in because I had already designed it in there. If you turn it on, the whole bot will vibrate, kind of like your phone. You've got a little counterweight right here. And that should possibly help it out of a sticky situation if it's like caught off its wheels in a corner or something like that. Let's see, we've got the 2 motors. These are 2 brushed DC motors. They are originally 3.7 volts. I am running them at about 7 to 8 volts, depending on the charge of the battery. Right here is the strip of LEDs that show through the top. That is for showing animations. It will you can either have it show a single line for the front direction, or it shows an animated opening and closing Pac-Man mouth, hence the name Pac-Attac. If I lift that up, we've got several chips here. This right here is just a generic bipolar transistor driver chip. It has several of those drivers go to the LEDs, so I can turn on and off individual sections, and then it also drives this motor right here. Right here I have 2 separate chips as the motor drivers, one for each motor over here for the drive motors. Those can go up to, I think, 10 amps. Of course, I don't really ever get that high in this bot, but that is a possibility for those chips. This right here is a little op-amp circuit that is adjustable, and it is used right here to detect that white mark. You can kind of see the opto-isolator over here. Not opto-isolator, sorry. It's got an optical sensor. It's got an emitter and a detector right there in that little box, and it detects when that white flash goes by. It's like my little tachometer for the wheels. In the center here, we have a accelerometer, just a classic MPU 6050. Oh, by the way, there's a 5-volt 7805 regulator power supply over here with that capacitor. Underneath the RC receiver is the Arduino. So we've got the Arduino there, and that can be lifted up for easy programming. If I can get it up with my finger. Anyway, that can be lifted up for easy programming. This right here is just a little Fly Sky receiver off Amazon. We've got the disconnect right here, power disconnect. That is homemade with a 3D printed part and a couple bolts and a screw and a spring. You can unscrew it to turn off power. There's the battery connector. Battery's removable. You just plug it in right there. And yeah, as we zoom out a bit, you can see there's 3 main 3D printed parts. This whole weapon right here is one part. The top frame is one part, and the bottom frame that has all the motor mounts is one part. I can easily swap out spares if needed. A lot of these hot glue pieces are fit in place. It's not necessarily glued to the plastic, so I can just pull that out. Most of the hot glue is mainly to hold wires and chips in place. Notice that I have ridges built into the bottom plate that go around the weapon area, and that helps so that the force exerted on when the weapon hits something, it's not just on these 4 bolts but it also puts it directly onto the frame as well. That way the whole thing is just more structurally sound, especially because it's spinning over hopefully about 1500, little under 2000 RPM is about its max speed. And I can easily swap out this weapon if needed. I will have several spares. But yeah, then I'll show you the bottom plate. It has that to hold the vibration motor in place. I add a tiny bit of glue there just to help keep those motors pushed down. They're just sitting in there, so you can push them down. Yeah, it is an exciting little bot that I hope will do well in its first battle in a couple days. It is pretty much perfectly balanced when it's all screwed together. If you hit it on one side, it'll fall to that side. Hit to the other side, it'll stay on that side. Balance in the middle, it'll stay in the middle. And I am very happy with it. I'll post the schematics as well if you're interested in seeing those. The code is a bit of a mess, but it is workable. It has a couple of modes. You can either use just the accelerometer, which is preferable. It's pretty stable in just the accelerometer mode. You can also use the tachometer only, or a manual mode where you just manually dial in the speed with one of the knobs on the controller. Of those three modes, the accelerometer is by far the smoothest, mainly because it isn't affected by the wheels slipping or anything like that. A couple other things to note. Let's see if you can see that. You can see that the 3D print has a lot thicker of a wall around on the weapon compared to just the normal 3D prints over here. And that should ideally help when it hits something. You can see if it hits something, it pushes that force along the rest of the frame here. And so I have not yet battled this bot. It might be a complete flop, but I have prepared everything that I know how to on here to make it successful. Go Pac-Attac. Thank you for watching.